we want to prove that 2 to the power of n plus 1 is less or equal to 3 to the power of n for every positive integer n. Okay? So we will start by giving it a name, p of n. Let's call that statement 2 to the power of n plus 1 less or equal to 3 to the power of n. This is the whole statement as p of n. Okay? So the base case is for n equals 1. So the left side, so let's see, let's compute 2 to the power of n plus 1 for n equals 1. That's 2 to the power of 1 plus 1. That's 2 plus 1, that's 3. And the right side is 3 to the power of n, which is 3 to the power of 1. This is 3, so they are equal. Okay? So because they are equal, we can say that 2 to the power of n plus 1 is less than or equal to 3 to the power of n. So 2 to the power of 1 plus 1 is less or equal to 3 to the power of 1. That means that p of 1 is true. Now let's do induction assumption. This is suppose that p of k is true. So suppose p of k is a given. This means that we're going to assume 2 to the power of k plus 1 is less than or equal to 3 to the power of k. So this is a given for k greater than or equal to 1. So some integer. So we want to show the statement is true for n equals k plus 1. So we want to show that p of k plus 1 holds. Okay? In other words, we want to show that 2 to the power of k plus 1 is less or equal to 3 to the power of k plus 1. So that's our p of k plus 1 statement. So let's check the left-hand side of this statement. This is 2 to the power of k plus 1 plus 1. This is 2 to the power of k times 2 plus 1. Now, I want to make it less than or equal to 3 to the power of k plus 1. What I know is 2 to the power of k plus 1 is less than 3 to the power of k plus 1. So let's break this into 2 to the power of k, 2 to the power of k plus 1, because there's 2 copies of 2 to the power of k plus 1. This is 2 times 2 to the power of k. 2 copies of 2 to the power of k, I mean. That's 2 to the power of k plus 1. So this one is less than or equal to 3 to the power of k. So I will write it as 2 to the power of k plus 3 to the power of k with a less than. This is by induction assumption. Now I want to make this less. So one thing we know is 2 to the power of k is strictly less than 3 to the power of k for k greater than 1. Since 2 to the power of k is less than 3 to the power of k, I will write it as 3 to the power of k plus 3 to the power of k, but less than, because I made it larger. This is 2 times 3 to the power of k. Well, 2 times 3 to the power of k is less than 3 times 3 to the power of k, which is 3 times k plus 3 to the power of k plus 1, because that's 3 to the power of 1 times 3 to the power of k. And this is the right-hand side. So in other words, the left-hand side, which is 2 to the power of k plus 1, is now strictly less than 3 to the power of k plus 1. Okay? For k greater than or equal to 1, actually. Well, strictly less than is when 2 to the power of k plus 1 is strictly less than 3 to the power of k plus 1, we can also make it less or equal. It's still true. Hence, p of k plus 1 is also true. In other words, we used p of k to get p of k plus 1. Okay? Therefore, by mathematical induction, P of n is a true statement for every positive integer n. In other words, 2 to the power of n plus 1 is always less or equal to 3 to the power of n for each n greater than or equal to 1. And that concludes the proof.